Hey guys, so we'll take a look at a program where I'm going to input two integer values and I will find the sum, the difference and the product and quotient. So this is basically finding, doing operations like what a calculator will be doing. I will also declare one more value to be found, let's say the remainder on dividing both the numbers. So these are operations which are associated with the 5 arithmetic operators. The sum is associated with the plus, the difference is associated with the minus, the product with the asterisk sign, the quotient with the division sign, and the remainder with a percentage sign, also known as the modulus sign. So we'll explore each and every of these operations together. Let's say I'm going to declare int a and b as common for these, and I will be printing f asking my user to enter the values of a and b, and I will go ahead and write scanf for inputting the values %d and ampersand a and ampersand b. So this much is done. I am doing this in advance because this remains common for all the 5 operations, but we will explore each operation one at a time. Now for example, you are going to have your sum operation which is associated with the plus. So whenever you do arithmetic operations, you should always be careful as to what are the inputs an operator can get and what is the output an operator can give. So whenever you do arithmetic operations, make sure that both the operators on either side of the operation is same. Like both the operands data type should be the same. Like if you add an integer and a float, you will get an integer. If any of the data type is different, the operator will do something known as an implicit type conversion, meaning whatever is the smaller data type will be converted to a bigger data type so that both the sides operands will be of the same data type. If you are adding an integer and an integer, you will get the integer as the answer. Like say 4 plus 5 and you will get 9. If you do an integer plus a float, the answer will be float and the operation will directly convert an integer to float. Like suppose you do 4 plus 5.0. What will be the answer? For that, first 4 will be converted to 4.0, then it will be added to 5.0 and the answer is 9.0. This is known as type conversion, implicit type conversion, meaning the compiler does the type conversion. We have one more type conversion known as explicit type conversion, which is forcefully converting your operand to another data type, but that we will see in the division operation. For sum, what I will do is, since both are going to be integers already, I have declared both as integer. Let me say declare an this one variable integer in sum for calculating the sum. So what will you do as the operation? You will do sum is equal to a plus b. Once you have calculated, you can directly go ahead and printf that you can either write it as a plus b is equal to %d and print the sum. Okay, you can do these operations. Instead of these 3 operations, you can directly go ahead and write a single statement like a plus b is equal to %d and write a plus b here. This is the part where I tell you that you can reduce writing the sum variable declaration. You can reduce writing this statement separately and just combine everything and write. We will do part by part in the code so that you will see how does the operations work and how to optimize it. Going ahead for the difference. Now the difference is noted by the minus sign. Now 2 things can happen in difference. If a is greater than b, then a minus b is going to be a positive sign. If A is less than B, then A minus B is going to be negative. You can do one way where I am going to declare an int difference, diff, and I am going to do difference is equal to A minus B, and I will printf the difference, like I'll print it as A minus B is equal to percentage D, and I'll print difference. Or in place of these, we can replace this with the statement printf A minus B is equal to percentage D, and just go ahead and print A minus B. So this one statement serves the purpose of the three statements. This is exactly like how we did the sum operation. Here also, if both the operands are integer, you will get your value in integer. If one of them is in float, the other will be implicitly converted to float, and your answer will also be in float. Now, there is one more method. Like when difference is calculated between A and B, some people would like to print the value of A minus B directly. But some people would like to find what is the difference. Like if it is A is equal to 4 and B is equal to 10, some people don't mind if it prints minus 6. But certain times you just want to find what is the difference. I mean to say, how many digits are there between 10 and 4? The sole difference. I do not want to know the sign. Like it will be equal to printing modulus of A minus B. I just want to know what is the difference between A and B, irrespective of the sign. If you are aiming to print the difference in such a case, we have a function which allows for this. The function's name is ABS. This is absolute value. Now ABS, what it will do is, it will take the absolute value of whatever you give inside. If you give ABS of 7, it will give you the value 7. If you give ABS of minus 7, it will give you 7. But you cannot put ABS of 7.5 because ABS works only on integers. When you want to do ABS of a floating point number, we have another function called FABS. FABS will give 7.5 and FABS of minus 2.3 will give you 2.3. This is only when you want to print the absolute value. This is just a function given in a header file called stdlib.h, not math.h, it is stdlib.h. It will give you the value of the fabs or the abs function. The stdlib.h is the header file that contains the definition for these two functions. So this is only if you want to print the absolute value of the difference. You just want to find the difference between the two variables. You do not want to know whether it is a minus sign or whether it is a positive sign. So that time you can just go about writing the printf sign as printf as /n. Difference is equal to percentage D if you're using abs. So you can go ahead and write abs of A minus B. You can go ahead and write this. So this will help you in identifying what is the absolute value of the difference between A and B. It will not tell you whether it's a floating point. It will not tell you, not a floating point. It will not tell you whether it is a minus sign or a positive sign. If you had to use the fabs function at all in any future values, any future operation, don't forget to change this to percentage f, because fabs will only deal with floating point and the answer will also be in floating point. Now moving on to product. In product, it deals with asterisk sign. This is exactly all same like the sum and the difference we had. If you are working with two operands of integer data type, your answer will be integer. If you are working with a float data type, the integer will be converted implicitly to float and the answer will be also in float. Here also you can go ahead and display integer variable named prod, and you can write prod is equal to A asterisk B. And you can go ahead and display printf a asterisk b is equal to percentage d, and you can print the variable prod. So I'll print this prod over here. Or you can replace all these three statements with a single statement, printf a asterisk b is equal to, sorry, it was not percentage f, okay, it's percentage d, my mistake, sorry. So you can go with percentage d and print a asterisk b. So this one statement will suffice in place of those four statements. So this is all implicit type conversion, and remainder is modulus. I am keeping division for last because there is one thing I want to explain. So we'll go with remainder, which is the modular sign, or it looks like the percentage sign. What this will do is it will give the remainder on division. Let's say you want 7 modulus 3. So what it means, 7 is being divided by 3. This will go 2 times. 2 3s are 6 and your answer is 1. Or if it is, so the answer is 1. If you're doing 5 modulus 3, it will be 5 dividing by 3, and this will go 1 time. 1 3s are 3 and the answer is 2. So this is 2. Imagine if you're doing the opposite way, where the smaller number is on the left hand side. 3 modulus 5. This answer will always be the answer on the left hand side, because think this is doing 5 divided by 3 is actually 5 modulus 3. This version is actually writing 5 outside and 3 inside. This will obviously go only 0 times and the remainder is 3. This can be for anything. Any bigger number you write on the outside and smaller number in the inside, it will always go 0 times, and the remainder is actually the number that is written inside. Meaning, if you write a small number on the left hand side of the modulus operation, the answer will always be the number on the left hand side. Now remainder or modulus operation, it does not work with float variables. That is the problem of remainder, because remainder always, if you had a float and you are dividing with a float, it will always do its division and give you values in float. It will, the quotient will always be in float. By normal float divided by float, you will get float. But remainder always takes a, has to have a remainder, meaning it does not go across a decimal point. So it does not work with float, it only works with integer. So keep in mind, modulus operation only works with integer data types. So we'll go ahead and put int remainder as the variable. So int rem, and you can write rem is equal to a modulus b, and go ahead and write printf a modulus b is equal to percentage d, always percentage d, and a modulus b. You can either write it, sorry, I will do the longer version. You can go ahead and write a remainder, or in place of all these three, you can write the simple operation of printf a modulus b is equal to percentage d and write a modulus b. So this is a remainder operation. Now comes to your division or the finding the quotient or the division sign. Now this also follows the same thing. Int divided by int will always give you int. Like for example, 5 divided by 3. What is 5 divided by 3? This will go 1 time is 3 and you will get the value 2. In a perfect world, we'll go ahead and do the division of adding a 0, adding a decimal point, bringing the 0 down, putting 6 3s are 18, and then going ahead and adding zeros, so you get 1.6667. But here it doesn't happen, because it's an integer divided by integer. At that point of time, it stops with where the decimal point is supposed to appear, and your answer will be 1. This is not the ideal division. This is what happens when you do division of integer. If you had done an integer by float, if any one of the operands was a float, if it is integer by float or float by integer, yes, of course, it will go ahead with the decimal points and the answer will be in float. This is the ideal case where you divide two numbers and you get the decimal point, because obviously in mathematics you do that. Our program is to do the same thing, implement exactly how you're doing it in mathematics in your computer. So for that, if my two variables a and b are going to be integer, I need to forcefully convert one into float. Only then my answer is going to come in float. So whenever you do that, you have to convert a variable into float. We call it as explicit type conversion, or in front of the variable, write the data type in a bracket. This will convert it into a float forcefully. So now if I am doing a float of an integer by integer, this is what I have. I have integer by integer, and now what I am doing is I am letting go of 1 and converting 1 forcefully to a float. Now what happens? It becomes a float by integer. Now this integer by default will get converted to float by the compiler and my answer will come in float. So division or the quotient will always be float. So if I do float division, I am going to write division is equal to float of a by b. You can put the bracket data type either on the numerator or on the denominator. It will work either ways. You can write it this way or you can write it as a by float of b. Both of these will convert E1 into a float. Now the answer is definitely going to be in float data type. You can go ahead and print f that division gives the value in %f and go ahead and print div. I am writing %f because this division I have declared in float data type. Now if I am not declaring the data another variable, meaning I am going to shorten this and write it, the answer of a float a by b or a by float of b is definitely going to be in float data type. So I can just go ahead and write printf a by b is equal to %f, and in that place I am going to write it as either float of a by b or a by float of b. At this point, do not forget to write this format specifier as %f. Okay. Now, I know this is a lot to take. What we'll do is, first we'll go ahead with writing all these three statements for each operation, where I'm going to declare, I'm going to do the operation, and I'm going to printf with the operator that is newly declared, and operand variable which is newly declared. And after that, I will do shorten it down, and you can see the operation in a much more compact way. So we'll go ahead and print, take two variables int a and b, and let's declare each of the operations as and when we face it. Okay, not right now. So we'll go ahead and do printf /n enter values of a and b, and scanf %d ampersand a comma ampersand b. Now we have to do the addition. So I'll go ahead and declare a sum variable in sum. I have to shorten this out, that's why I'm declaring it now and not at the beginning. Sum is equal to a plus b, and the printf was printf /n sum is %d and the value was sum. Now int difference is equal to, I'll show you the other method also, where you have to just want to find out the values of just the difference without the sign. So difference is equal to a minus b for now, and printf /n difference and gets the value of percentage D, and this will be DIFF. Okay. Next, I'll go ahead and declare int prod. So prod is equal to A asterisk B, and printf /n product is percentage D, and this will print PROD. Now the other one is int quotient. Sorry, that would be float quotient. So float quotient, quo I'm writing, quo is equal to, I'll put the float conversion on A. I'll do it with B as well, and go ahead and printf /n quotient is percentage F here alone, and go ahead and write quo, and then comes your reminder. So int rem main, so rem is equal to A modulus B, and printf /n remainder gets the value percentage D, and it is REM. So I think I've done, yes, almost everything. I'll see if I face an error. Okay, I'll run the program and enter the values of A and B. So I'm going to enter 10 first and 20 second. So it prints 30, difference is 10 minus 10, product is 200, quotient is 0.500, and remainder is 10. I'll reduce the quotient to a size of, let's say, 0.2 F, because I want the size to be gone. It's a little reduced. So I'll do A is equal to 15 and B is equal to 20. Let's see. And the sum is 35, difference is minus 5, and product is 300, quotient is 0.75, and remainder is 15. Here I told you if A is less than B, the remainder will be the value of A for A modulus B. Now the changes what I wanted to tell you was an ABS function. Here we can see for 15 and 20 that the remainder is minus 5. Difference is minus 5. I just want an absolute value for the difference. And here for the next I will change the float to B. So I'll change the float to B and I'll run. So now since I have the ABS, I need #include math.h, and I'll run it once again. So the values of A and B, I'll give same 15 and 20. Now see the difference is given as 5. It's just a normal difference, unsigned value, just the difference, modulus of the difference is found. Now quotient, it still becomes 0.75 even after I've given the float explicit type conversion on the value of B. Now shortening our program, I'll remove these two because I don't need this, and I'll put the value over here as A plus B. Now difference, we'll see the absolute value later once again, and I'm just putting difference as A minus B right now. I'll find the value of absolute later. Go ahead, and product, we don't need any of these. We can shorten it and write in place of the product as just A asterisk B. And quotient, instead of the quotient, I will do this. Since we know both the values are going to be the same, only in difference the values will change among what I just did. The other two, the values are going to be same for quotient. So I'll reduce the purpose of wherever I put the float, and for remainder also I'll change it and give REM as A modulus B. See, I have drastically shortened down the program, and we'll run the program for the same values of 15 and 20, and yes, it prints the values. Sum 35, difference minus 5, product 300, quotient 0.75, remainder 15. Now I'll put the ABS function here just for the difference part. I'm not going to change the quotient part because it's the same value wherever you put the float, either on A or on B. I'm going to run the program and I'll do the same for 15 and 20. The only difference you'll find is in the difference variable that is given as 5. So like I said, always like before, start your program in a bigger way, find out get a proper working output, and then you can shorten your program, and so that you will get a more compact value. Earlier I had a very big program, now I've got a very short program. All I've done is, in the printf statement, instead of having another variable, I've just put the operation at the place where the variable should have been there. Thank you.